Record right here while we're at it. Okay. Normally, I show an awesome video of how a sine curve becomes the derivative. And every time I show that math video, I think it's cool, and no one else does. Remember the last video I showed you all? So, for sake of time and for sake of you guys being bored to tears, I'm not going to show that video, but if you want to look it up, it's pretty cool. It actually takes the sine curve and it finds the slope. Why would it find the slope? That's what a derivative is. So at every point, like guy does, every couple of points, he finds the slope. And then he graphs the slope and its point of tangency again, and it creates the derivative of sine. And I know, it's very cool. It's called investigation, derivative of sine investigation. I was like, oh yeah, let's watch it. 9 minutes of him doing this. And I remember like I showed it last year and literally all of them were like, really? Or is this guy not done yet? It's really, I know, they're ungrateful to the. So Mrs. Seta is gonna save the time right now. And you're just going to go with the fact that, yes, Mrs. Seta, I believe that you are going to tell me the truth right now about what is the derivative of sine, okay? So, that looks weird. So, the derivative of sine x, also known as sine u. Why am I saying that weirdly?
The chain.
You're so smart. You're the smartest children in all of America, okay? The derivative of sine is cosine. If you were to graph the slope at each tangent line, and then graph the slope and its point of tangency, it actually would create the cosine curve. What? And like that's why I was like, isn't this amazing, guys? On the video, and they're like, no. It was so sad. Like every year I do this, so I'm saving you all. I'm saving. All right, derivative of tan, secant squared x. Secant squared. Derivative of secant x is secant x times tan x. How weird is that? Now we're going to do the derivative of all the c's because they're the strange ones. The derivative of cosine x is actually negative sine x. It's actually the flip of your sine curve. The derivative of cotangent x is negative cosecant squared x. And then the last one we'll be concerning ourselves with today is the derivative of just cosecant, which is negative cosecant x cotangent x. Now, for those of you brave enough to do the SBCC course, you have to memorize this. But I'll be honest with you, probably in Calc 2, you will have to have it memorized. Everybody else, you get a note card. Yay! I know. And that's when everybody's like, thank God I don't think I. No. I'll be honest with you, I don't even remember it. I remember these two. I do remember this on occasion and even this one. I don't know why. Sometimes it just sticks in my head. Actually, I do know why, but I'll tell you later off the camera. It's inappropriate. That's why. It's again, public school. Was a public school teacher before this. Sorry. All right, so we're going to find the derivative. Remember the chain rule. This is where, if you have any struggles today, that's where the struggle will come from. So I will start you off easy. Sine of 2x, y equals cosine of 3x minus 1. Y equals tan of x over 2. And then we'll do one more. These are like what I call the easy breezy ones. Then we'll do some mediums. We haven't even begun the hard ones yet. So I know. You're like, great. Great.
What's number 3
tan of x over 2. I'll just bring it up. God bless. You ready for the funness, oneness? You are. Okay. So, if you see a sign and there's anything after it, okay, that is your U. If it was just sine of x, you would just take it like you normally would, take the derivative of sine x. But this is a u, okay? So the way you take the derivative of sine of anything would be you write what? Cosine of that anything. So the derivative of this would be cosine of 2x. However, since this is not just x, it's 2x, you have to attach the chain, which would be, what would be the derivative of that? 2. Do not put times 2 and call it cosine 4x. Don't do that. Cosine 2x cannot be separated. You can never separate this out from the cosine. So what I would suggest you do is put the 2 in front. So really, your final answer should be 2 cosine 2x. The 2x can never be changed. You can't factor out of that. No, no, no. What now? We do know that sine 2x has an identity. That's a double angle identity. Agreed? And you could take the derivative of that if you want to. It's not worth it because it's much easier to take the derivative of that one. All right? And that's it. There's that first one. U prime being 2. So what do you think number 2 would be? What do you think the derivative of cosine 3x minus 1 would be?
3 times cosine 3x.
Ooh, I like that you already attached the chain. Very good. So again, the cosine of anything would be negative sine of that anything, but then you have to attach the chain of what's on the inside, which would be 3. And that 3 is being multiplied. I put it in the front, okay? So I would actually call this negative 3 sine 3x minus 1, okay? So far, so good? I think a lot of you still kind of get confused about this right here. If you see this, don't be like, quotient rule? No, 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 no. Okay, not yet. This is a monomial. Another way to write x over 2 would be what? What? 1/2 x. Oh, okay. So take the tan of 1/2 x. Well, tangent is secant squared x. So you would write secant squared 1/2 x. But then you have to times it by the what? What by what?
The chain.
What would be the chain? 1/2. And again, I like to put it in front. So the answer, you can leave it as 1/2 secant squared 1/2 x, but I want to let you and remember what this actually squared part means. When you put the squared next to the secant, what that actually means is you are doing this, 1/2 of secant 1/2 x, and you're squaring this entire thing. Well, then why do they put it down here? It's all for just getting rid of a parenthesis. The people of years past and prior math, that was the whole purpose of putting a squared there, was just so they didn't have to write a parenthesis here. Okay? But that's what it means. That's really what it means. So if I ask you to actually find a value when x is 2, then you would have to plug 2 here. And actually, I would do it into this one. I would say 2 times 1/2, what's the secant of 1, square it, then multiply by 1/2. Like that funness. See, you're excited. I can see the love coming. All right, what about number 4? So what's different about 4?
You have 6x as the chain.
Okay, what about this 2?
It just stays there.
It just stays there. Why does it stay there? Because it's a coefficient. Anytime you just have a 2 or a 5 or a half or negative, you just add it along. But if it was a 2x, oh, you'd have to do something different. Okay? But if it's just a 2, you just attach it there to take the derivative of cosine, which is what? Negative sine. Keep it 3x squared, but then attach the chain of 3x squared. What's the chain of 3x squared? 6x. Now, how can I simplify this? You can put the 6x with the 2 and with the negative. So that would be what? Negative 12x sine 3x squared. I don't want you guys to get confused with the last time we took derivatives. You are not allowed to bring that 2 in front. We're not doing logs. We're not doing ln's. Logs have power properties. Somebody in the other class was like, can I bring that 2 up here? I'm like, no, that's not a log. It's not a log. Okay? Yes, Ashley.
On number 3, is there any reason to make it x over 2 again, or just leave it 1/2?
You could. It doesn't matter. Okay? All right, so that was easy.
I think I missed the easy part.
Little too easy. Thank you. Ready?
Tell me how to do it, man. Did I miss anything?
Nothing. And these we'll call medium. Sine cubed x, cosine 4 2x, square root of sine 4x. You ready? Because a lot of students forgot this. Hopefully you're different, because I believe you to be different and smarter. You, Reese. You work smarter, not harder. I mean, that's you by nature. All right, here we go. Y'all, I just told you what this 3 means. What does that 3 actually mean to this problem? So it means you cube the whole thing. Harken back with me to a time when we had things like this. What did you do? You what? You cubed. You wouldn't FOIL this out 3 times. No, 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 you moron. You would call this u, wouldn't you? And then you would take the derivative of u. We're going to do that here. Are you with me? Okay, so scratch this out, scratchy, scratchy. So my u is sine x. That's what's inside. Anytime I have a parenthesis and a power, anytime it's a parenthesis and a power, I call that whatever's in the parenthesis u. Then I take the derivative of it. What is the derivative of that? Cosine x. And then I rewrite this as u cubed. Y equals u cubed. Now I take the derivative. What's the derivative of u cubed? What would be just the derivative of like x cubed? What would it be? 3u squared. But then I attach the chain. I always attach the chain. And then I replace these where I see the u. So now I would have 3. Instead of u, I'm going to write sine x squared. And then instead of u prime, I'm going to put cosine x. Now, another way to write that would just be putting the 2 next to the sine, because that's what's being squared. So 3 sine squared x cosine x, because for whatever reason, we just don't like parentheses. How did you feel? Did you get lost?
Everywhere.
Why is this a u, but this one isn't? Why is it different? Because the whole thing is not going to a power. This is the only thing that's the u. Whereas here, if the whole thing is going to a power, then that is your u. Does that make sense?
Right.
Either if something's going to a power, that's your u. If it's not going to a power, then the thing next to it is the u. So then look at number 6 with me. How would you start that off? What would you do? Rewrite it as cosine 2x to the 4th. Okay? So then what is my u? What's my u? Cosine 2x. Oh, wait. What is my derivative of that?
No.
Negative. It's
Negative
2
cosine
2x.
Nice. You just did this problem like this over on this side, didn't you? Except with sine. And what did you do? You're like, oh, that's really easy, Mrs. Setta. Cosine 2x, and then you multiply. Yeah. How come you can't do it when it's over here? For whatever reason, all my children forget this. Cosine, the derivative of just this, ignore that. The derivative of cosine 2x would be negative sine 2x, and then multiply by the chain, which is 2. So I'm multiplying by double. Yes, you have to. You have to take the derivative of what's inside. All right, so now that we have our u and our u prime, now I'm going to rewrite this as u to the 4th, and I'm going to take a derivative like I just normally would, a u to a 4th. The derivative of u to the 4th is 4u cubed times the chain. Now I substitute it back in. So that would be 4 times what? cosine 2x cubed times negative 2 sine 2x. I don't like the way that looks. I want to clean this up. What is allowed to be together?
4
Negative.
The 4 and negative 2,
You with the 3 on the cosine.
and then I put the 3 with the cosine. Never, ever, ever think like, well, Miss Setta, can I just factor out a 2 here? No, no, no. You cannot touch what's next to the word cosine. You cannot touch that because that would be like me saying cosine 30. Oh, Mrs. Setta, can I factor out a 2 from cosine? No, no, no. Cosine 30, it's a number. We actually know what that number is, but it's a number. You don't factor out. Tyler.
Do you care like if sine goes first or cosine goes first?
I do not care, actually. That's correct. You could flip-flop these, by the way. Okay, so that's fine. But I do like the coefficient to be in front and like any x squareds or whatever in front. Okay, one more. I'm going to let you do this one. The square root of sine 4x. I'll set you up. That's the same as saying sine 4x to the 1/2. Oh, it must be a u because anything to a power is a u. What? Nah. I think rationalizing this one actually looks uglier and it's much more simpler to not.
I don't know how to do it all. I'm just kind of copying down the thing. I'll listen to the video later.
Will you do your homework?
Yeah, I will. Sorry. For how you over the way things are already late.
All right, so my u is sine 4x.
I'll figure it out.
Okay. If I take the derivative, I hope you have this. 4 cosine 4x. Where did the 4 come from? It's the derivative of this u, but I thought this was the u. There's 2 u's. It's a double u. Yay! Okay. So then I would rewrite this as u to the 1/2, and I take the derivative of it. So that'd be 1/2 u to the negative 1/2 times the chain. And I replace once I get this far. So 1/2, my u is sine 4x to the negative 1/2. My u prime is 4 cosine 4x. And now put things together. The 1/2 can go with this 4, not with the 4x. You don't touch the 4x. What's 1/2 of 4?
2.
2. So 2 is on top. Cosine 4x is on top. But this guy goes where? On the bottom. And you can put it as a root, or you could put it to the 1/2. I don't care. This is what Tyler was talking about. Do I rationalize it? It actually looks nastier if you rationalize it, because then you would have a root on here and a root. It's not worth it. So that's your answer.
Oh, so you don't multiply it. You know what?
Yeah.
Don't multiply the 2 and the 4, but you can.
Yeah, no, don't do it. All right. Let's do just one more, just for fun, and I'll keep it nice and simple.
You're gonna be like any hard ones on that homework.
Hard.
Is 43 gonna be the hardest one? I feel like 43
Hard.
is always the worst one.
33.
What you gonna do this one?
But you go and
You're gonna product rule.
Right. How do you know this is a product rule and the other one wasn't a product rule?
Because it's an X squared.
It's an x squared, or if it's got a monomial in front that's not a just coefficient. The coefficients tag along. This is a monomial, so you are going to have to do a product rule here, okay? So we'll separate it like that. And again, if you don't remember product rule, you should have it ingrained. It's first, and I actually was really nice. I didn't even give you a u here, which I should have. Just letting you know, though, SPCC friends, it's there. I know, good times. First times derivative of the second, which would be negative sine x, plus second times derivative of the first, which is 2x. Again, do not ever touch that x. That 2x goes to the front. So the way I would rewrite this would be negative x squared sine x plus 2x cosine x. Cannot touch that. Could you factor out an x from these two? Yes, but don't write it in factored form. Just leave it like this, actually. This is the better way to leave it. Okay, welcome to the first part of Trigs. We haven't touched the hard ones yet. Remember, these are medium.
Oh,
Page 585. You're going to do 1 through 19 odd, 37, 43. Will there be implicit on there? I might be.
How do you do that?
Will there be find the tangent line? Could be. You should know how to do all this. Okay.
Can someone pass a bigger textbook, the full, and just send a picture?
Oh yeah, some of the people have the half textbooks, so they need it.